Dear student, in this video we are going to discuss region of convergence for Z transformation. As we have already discussed in the last lecture, xz is equal to summation n is equal to minus infinity to infinity xn z raised to the power minus n. This equation, in this equation we have put z is equal to r into e raised to the power j omega. If we will take mod both side, and now we will see we are seeing that what will be the ROC of Z transformation. So to see, this is the region of convergence, means at what value the value of xz will be converged. So mod of xz should be less than infinity. Uh, uh, in the same way, if we'll see at the right hand side, then this mod should also be less than infinity. E raised to the power j omega n is its mod is 1. So we have written here summation n is equal to minus infinity to infinity mod xn r raised to the power minus n is less than infinity. Now, region of convergence. What will be the region of convergence for Z transform? This is the Z frame. This is a Z plane, and at the x axis we have taken real of Z, and at the y axis we have taken imaginary part of Z. As we have already discussed, then we have taken the value of Z is equal to e raised to the power j omega. Here we have put r is equal to 1, or we can also take it r is equal to r. The value of r can be anything. So if we will see from this value z is equal to r into e raised to the power j omega, then we will see that we will get a circle whose radius will be r, because r is not going to change, and but the omega can be changed. So at any value of omega we can get any radius from the origin. So the length of the radius will be same throughout the circle but the angle will be changed, so we will get the circle. So these are some properties of ROC. We have already discussed that the ROC of xz consists of a ring in the z plane centered at the origin. If xz is a rational, then the ROC must not contain any pole. If xn, now these are the three property which we will also see in the factorial form. If xn is a right sided and infinite duration, then ROC is outside the circle of the radius of outermost pole. And if xn is left sided and infinite duration, then our ROC is infinite. ROC is inside the circle of the innermost pole. And the third one is xn is two sided and infinite duration, then ROC is a ring in the z plane. Now all these three properties we will see in the pictorial form. These three one. In the first one we have shown for right sided secant which is infinite in duration. So we get ROC outside of the unit circle or of circle radius r, outside of the circle. If xn is left sided and infinite in duration, then we will get the ROC inside the circle. And if the xn is both sided and infinite in duration, then we will get a ring. And here we can see that r2 is less than mod z is less than r1. It means the radius of innermost circle is r2, and radius of outermost circle is r1. Now afterwards we will see these three properties. If the xn is right sided and infinite in duration, then ROC is the entire z plane except z is equal to 0. If xn is left sided and finite duration, ROC will be entire Z plane except Z is equal to infinity, and if it is two-sided and finite duration, then ROC will be entire Z plane except Z is equal to 0 and Z is equal to infinity. Again we will see it in pictorial form. When the axon is right sided in finite duration, it is the entire Z plane except Z is equal to 0. When the axon is left sided, then ROC is the entire Z plane except Z is equal to infinity. And when it is both sided and finite duration, then ROC is the entire Z plane except Z is equal to 0 and infinity. Now we will see the effect of ROC in the form of numerical. This is the numerical problem. Determine the Z transform of xn is equal to 1 upon 2 raised to the power n un plus 2 raised to the power n un. Here we can observe that here un is given. So un is a right sided sequence, and what is this? Infinite in duration. So depicts the ROC and the locations of poles and zeros in the Z plane. Now we will solve it. We know the formula xz is equal to n is equal to minus infinity to infinity xn z raised to the power minus n. Here we have put the value of xn, that is 1 by 2 raised to the power n un plus 2 raised to the power n un. Because there is un, so the limit will be 0 to infinity, and after solving this we get these two terms. First term is this, and first term is 1 upon 1 minus 1 upon z inverse, because this is the infinite length GP, and second term 1 upon 1 minus 2 z inverse. Therefore, for first term we can see that the ROC is mod z is greater than 1 by 2, and for second term the ROC is mod z is greater than 2. Then if we will these are the two poles at z is equal to 1 by 2 and at z is equal to 2. So when we'll draw two circles at 1 by 2 and at 2, so as we have seen in the properties of ROC, that if the sequence is right sided and infinite in duration, then the ROC will be the outside of the outermost pole. So outermost pole is 2 here. We have shown by cross. First pole is 1 by 2 and second pole is 2. Then the outermost pole is 2. So ROC is the outside of the outermost pole. So this is the region of convergence, shaded area in this. Now we will see the same problem for left sided sequence. Now the problem is determine the Z transform of xn is equal to minus 1 upon 2 raised to the power n u minus n minus 1 plus 2 raised to the power n u minus n minus 1. Here we can see that this is the left sided sequence. Now again we will take the formula of Z transform. Xz is equal to summation n is equal to minus infinity to infinity xn z raised to the power minus n. We will put the value of xn here and put the we will put the limits according to u minus n minus 1. So the limit will become minus infinity to minus 1. Here we have put the limit also. After solving this, we get these two term again, 1 upon 1 minus 1 upon 2 z inverse minus 1 upon 1 minus 2 z inverse. Therefore, for first term, the ROC is inside the inside the circle of radius 1 by 2, and for second term the ROC is inside the circle of 2. So as we have already discussed in the property of ROC, that ROC will be the will be the region in the jet plane inside the innermost pole. So in this case, innermost pole is 1 by 2, because there are two poles, 1 by 2 and 2. So innermost pole is 1 by 2. So the ROC is the inside region of the circle of the innermost pole. So this is the shaded area shown in this figure. Thank you.